To understand Google's new open model, PaliGemma, we first have to look at the paper for its closed-source predecessor, Pali 3.
The abstract makes a bold claim right away. It says Pali 3 compares favorably to similar models that are 10x larger. That efficiency is the core theme here.
10 times larger. That's not a small difference. That's the difference between a research project and something you can actually deploy.
And the key to that efficiency is a component called SigLIP. The paper compares traditional vision models to these contrastively SigLIP pre-trained ones.
So a traditional model learns to name an image. This is a cat. What's the SigLIP approach?
SigLIP learns the relationship between an image and text. It learns that the image of a cat is more related to the phrase "a cat on a mat" than it is to "a dog in a park."
There's a trade-off. For simple classification, SigLIP is slightly underperforming. It's not the best at just labeling.
But it has superior performance across various multimodal benchmarks, so it's better when you need the model to understand both images and text together.
Exactly, especially on tasks like visually situated text understanding. That means reading text that appears within an image, like a street sign or a product label.
So for Pali 3, they decided to really lean into this SigLIP component. They scaled it up.
They did. The image encoder itself, the eyes of the system, grew to 2 billion parameters.
And it paid off. That decision led to a new state-of-the-art on multilingual cross-modal retrieval. That's a huge result.
And the entire PLI-3 model is only 5B parameters. For context, many flagship models today are hundreds of billions. This is genuinely small.
Which models are they comparing to when they say similar models?
The paper doesn't name them, but given the time frame, they're likely referring to other large proprietary VLMs from 2022 and early 2023. This was a direct shot across the bow.
I love the mission statement at the end. They hope Pali 3 rekindles research on fundamental pieces of complex VLMs.
It's a call to the community to stop just making models bigger and start making them smarter. The goal was to fuel a new generation of scaled-up models based on better components.
This feels like a recipe, not just a result. They're showing their work, saying, here's a better way to build these things.
It's fitting this is on archive. The whole site is built around that principle of sharing knowledge, even experimental projects.
Pali 3 proved the recipe worked. Now let's see how Google turned that recipe into an open-source model anyone can use. Pull up the Hugging Face blog post. Here we are, the official announcement. This is the practical guide for PaliGemma.
The first sentence is the simplest possible definition of a VLM. It can take in an image and a text and output text.
Okay, and they released 3 versions right away: pre-trained, mix, and fine-tuned. What's the difference for a developer?
Pre-trained is the raw base for custom work. Fine-tuned is for academic comparisons. The mix model is the one you'd use for general-purpose testing.
Let's get to the architecture. How did they build it?
It's a modular design, just like the Pali 3 paper hinted. They took the SigLIP vision encoder and bolted it onto the Gemma 2B language model.
So SigLIP provides the eyes, Gemma provides the voice, and this linear adapter is the bridge between them.
That's a perfect analogy. It's a very simple, lightweight bridge that translates the visual information into something the language model can understand.
They also offer different resolutions. I assume higher is always better?
Not necessarily. The blog is very clear. High-resolution models require a lot more memory to run, and the quality increase is small for most tasks.
This is a key takeaway for builders. Don't default to the biggest model. You'll burn cash for a tiny gain. The 224 version is probably fine.
Here's that warning again. It is a single-turn vision language model not meant for conversational use. It answers one question about one image. That's it.
So how do you tell it what to do? It sounds like you give it instructions in the prompt itself.
Correct. You control it by conditioning it with task prefixes, such as detect or segment. The prompt isn't just the question, it's a command.
The detection capability is fascinating. It outputs bounding box coordinates directly in the text.
And in the specific order, ymin, xmin, ymax, xmax. Developers can parse this text output to draw boxes on the original image.
It's like a little API call. You get these normalized coordinates and then do some math to place them on the image.
The process is completely defined. You take the token value, divide the numbers by 1024, then scale by image dimensions. It's deterministic.
It can also do segmentation. What is referring expression segmentation?
It means you can ask it to segment not just a cat, but the cat sleeping on the couch. The language refers to a specific object and the model finds it.
This seems powerful for more than just photos of cats. They mention document understanding and reasoning capabilities. You could point this at an invoice or a chart.
Moving down to the How to Run section, this is where the rubber meets the road for developers.
First step, you have to accept the Gemma license terms and conditions. It's open, but not without rules.
And look at this. The example code shows how to load in 4-bit. This is huge for accessibility. It means you can run a powerful VLM on a consumer-grade GPU.
The blog even gives a look under the hood at the inference process. What's a key detail here?
This is critical. An additional new line token is appended to the prompt. It's noted as an essential part of the input prompt.
Why does a single new line character matter so much?
Because the model was trained with it. If you omit it during fine-tuning, your prompts won't match the structure the model expects. Your results will be garbage. It's a tiny detail that can break everything.
So many practical tips here. Now let's go to the source of truth for a developer, the model card on Hugging Face. All right, we're on the actual model card. This page is like the README for the model itself.
The first thing I see is the variety of inference options. They have instructions for transformers, but also for tools like VLLM.
What is VLLM for?
It's a high-performance serving engine. This tells an enterprise developer that the model is ready for production-scale traffic, not just notebook experiments.
They even have a use Docker command. That's about as easy as it gets. One command and you have a running model.
And there's the license gate again. It's public, but not anonymous. You have to accept the conditions to access its files. This is for tracking and responsible use.
Let's scroll down to the model details. What does the official summary say?
It emphasizes that PaliGemma is based on open components such as the SigLIP vision model and the Gemma language model. This is the recipe in action.
The purpose is explicit, designed for class-leading, fine-tuned performance. They're not giving you a finished product. They're giving you a high-performance engine.
The architecture section confirms the modularity. The text decoder is initialized from Gemma 2B and the image encoder from SigLIP SO400M by 14. Two separate, proven models joined together.
Let's talk about what it was trained on. This is always a critical question.
The primary dataset is WebLEI, which is a web-scale multilingual image-text dataset. This is where its ability to understand a huge variety of concepts comes from.
And they specifically augmented other datasets to translate into 34 additional languages. Multilingual support wasn't an accident. It was a design goal.
This next section is vital.
They detail the data responsibility filtering that was applied to the training data.
It starts with the obvious things, like pornographic image filtering, but it goes deeper than that.
They also use text toxicity filtering via the Perspective API. They're not just filtering bad images, they're filtering images paired with toxic text. This dual filtering is a non-obvious but crucial step.
And personal information filtering to protect privacy. This level of documentation about data cleaning builds a lot of trust for developers.
And for the third time, here it is, not meant for conversational use. They are being extremely clear about the tool's intended purpose.
This is the non-obvious connection for me. They repeat it so much because they want developers to think of this as a component, like a library, not as an end-user chat.
Let's look at the code example for running it in transformers.
Wait, the example prompt is S for Spanish, and it works?
Yes, this directly connects back to those multilingual datasets we saw. It learned to associate S with Spanish. It's a powerful demonstration of the pre-training.
What's this revision equals bfloat 16 part of the code?
That's a pro tip for builders. It tells Hugging Face to download the model weights in a more memory-efficient format. It cuts GPU VRAM usage almost in half with minimal quality loss. A huge win.
And the final piece for running this on a budget, pip install bits and bytes accelerate. What does this unlock?
It enables loading in 4-bit, 8-bit. This technique, called quantization, is what lets a 3 billion parameter model fit onto a gaming GPU with 8 or 12 gigabytes of VRAM. It democratizes access.
PaliGemma really is an open recipe. It's small, efficient, and transparent about how it's built and how to use it. A powerful new tool for developers everywhere.
The modularity is the future. Proven components assembled well. I'm Arjun.
And I'm Maya. See you tomorrow.